Good afternoon to all.
Good afternoon, sir.
Good afternoon. कैसे हैं सब? तो क्यूबिक स्प्लाइन इंटरपोलेशन आज डिस्कशन करेंगे ना? Cubic spline interpolation today we'll discuss. So actually what is the cubic spline interpolation and how to solve the problems? There are three alternative methods for cubic spline interpolation method. The first two, what is the cubic spline interpolation? A cubic spline interpolation.
Cubic spline interpolation. Lata thi khata bumdo.
Okay. A cubic spline interpolation क्या है? First we will discuss now. So what is the meaning of the cubic spline interpolation? Means a cubic spline interpolation will satisfy the following properties. Properties we can put.
कहाँ गेले?
Properties. You can mute yourself. Properties. First condition, capital F xi which is equal to f of I, and I is equal to 0, 1, 2, 3, etc. up to n. This is the first condition. Second condition, on each subinterval, xi minus 1 to xi. Condition that 1 is less than equal to I less than equal to n. Fx is the third degree polynomial. Capital Fx is third degree polynomial. Third degree polynomial, just you have listened. So Fx is the third degree polynomial. Capital Fx, third point. Fx, f dash x, and f double dash x. Are continuous on AB. So this is the third point. We denote f dash x which is equal to mi, and f double dash xi which is equal to capital Mi. Cubic spline do not have disadvantages of the quadratic splines. So three properties just you look out here for the cubic spline interpolation. First one is f xi is equal to fi. for I is 0, 1, 2, 3 up to n. Second property, on each subinterval xi minus 1 and xi, where the condition I lies 1 to n, and just capital Fx represent here the third degree polynomial. Capital Fx, capital F dash x, and capital F double dash x are continuous on closed interval of AB. And some points to this denote here, capital F dash x is equal to small of mi, and F double dash xi, which is represented here as capital of mi. The cubic splines do not have the disadvantages for the quadratic splines. On each subinterval, that is first subinterval xi minus 1 to xi. On each subinterval, that is xi minus 1 to xi, we approximate a polynomial fx. We approximate a polynomial fx just on this interval, and is a cubic polynomial. Then capital Fx as represented in the cubical form as capital F x, which is equal to polynomial of I of x, which is equal to ai x cube plus bi x square plus ci x plus di, and the value of I, which is equal to 1, 2 up to n. That is a cubic spline interpolation polynomial defined here. AI, BI, CI, DI are the four unknown to be determined. Here is, you look out here, AI, BI, CI, AI, BI, CI, and this value 4 unknown and to be determined. To be determined this values. Using the continuity property of capital Fx, capital F dash x, and capital F double dash x, some equations of continuity we have considered here for solution of this problem. The continuity equations we consider here. So what are the continuity equations? Continuity equations. Of f of x. On the interval wise, we can consider the continuity equation. The first interval on xi minus 1 xi. Pixi is equal to f of I, and which is equal to ai xi cube plus bi xi square plus ci xi plus di. Again, another interval on xi to xi plus 1 pi plus 1 xi, which is equal to f of I. And that is polynomial becomes ai plus 1 xi cube plus bi plus 1 xi square plus ci plus 1 xi plus di plus 1. Now these are the property of the continuity function of f of x. And I value becomes 1 to n minus 1. I is 1 to n minus 1. The continuity for fx, again, continuity for f of xi. Continuity for f dash x. That means that is the derivative part of this function. The derivative of this first function 3ai xi square plus 2bi xi plus ci, which is equal to 3ai plus 1 xi square plus derivative of this value is equal to derivative of this value. That is the second continuity property. 3ai xi.
slide
Okay. You have to see this one. Clear? Then next, लिखो.
Yes, sir. Complete हो गया.
Okay. The continuity of f dash xi means derivative of the above equation को हम equalize कर देंगे. That means 3ai xi square plus 2bi xi plus of ci, which is equal to 3ai plus 1 xi square plus 2bi plus 1 xi plus ci plus 1. That is the continuity function for f dash xi. Third property, continuity for f dash. Continuity for f double dash xi. Again, we can differentiate that function. 6 ai xi plus 2bi, which is equal to 6 ai plus 1 xi plus 2bi plus 1. These are the continuity function for third or f double dash function. At the end points x0 and xn, we have the interpolating conditions. At the end point, x0 and xn, we have the interpolating conditions. Interpolating condition. What are the interpolation conditions? F0 and Fn. F0, that is A1 x0 square x0 cube plus B1 x0 square plus C1 x0 plus D1. Fn, An xn cube plus Bn xn square plus Cn xn plus Dn. At the end points x0 and xn, we have some interpolating conditions, and that interpolating condition is that f0 and fn, here is mentioned, these are the f0 and fn. Then just to simplify, 2n minus 2 into n minus 1 equations from the above equations, we need 2 or more equations to obtain the polynomials uniquely. In most of the cases, we have to consider f double dash x at the two endpoints. That is, some of the cases we have considered. What we consider? Now that is f double dash x 0, which is equal to m0, and which is equal to p. Hello.
सर थोड़ा सा डाउट लगा, वो जो fn है ना, वो an+1 होगा या an नहीं होगा?
fn n नहीं होगा, not n,
क्योंकि f0 में जो है वो a1,
ये up to a, this function is considered up to n minus 1, right? This interval is considered up to first and last one we have not considered. Up to 1 to n minus 1 we have considered in this interval, right? First and last term we have considered in this last final cases. At the end point x0 and xn we have considered, and there is no n plus 1, only for f0 fn. a1 and an is there.
okay.
Okay. That's f0. In this case, we just substitute f double dash x0 means at the first point of the functional continuity function, m0 we consider, and that is also p. And last point f double dash xn, that is equal to mn, and that is equal to q. In the end condition, m0 is equal to 0. The end condition, m0 is equal to 0, mn is equal to 0. m0 is equal to 0, mn is equal to 0, lead to a natural spline. These two functions lead to a natural spline. Natural spline. And it is called natural splines. In the drafting, spline waves behaves in this fashion. And we need to simplify the above equation, then we can found A0, A1, B1, C1, D1, A2, B2, C2, D2, all constants we have to found and put this equation, and that is our requirement cubic polynomial. Okay. So just we need to solve one example. Then you better understand of this problem. Obtain a cubic spline interpolation. Obtain the cubic spline interpolation. Of the following data. In that data, x is given and fx is given. X 0, 1, 1, 2, 233, and 3 to 24. With m0 is equal to 0, and capital M3 is equal to 0. Hence, find an estimate. Hence, find an estimate. F 2.5. Just you can see this example for solution of the problem. So just you look out here, how many intervals you have to consider here. Intervals is 0 to 1. This is first interval for cubic. Second interval 1 to 2. Third interval 2 to 3. So that's why m0 is equal to 0 and m3 is equal to 0. This is first point and this is the last point. X0 and xn. For solution of this problem, write the cubic polynomial approximately. Solution. Just we write the cubic polynomials. Cubic polynomials. Cubic polynomials. Actually, what are the cubic polynomials? Just to define here, 3 intervals we consider. Interval wise, we can define the cubic polynomials. Fx or fast polynomials. P1x. That is equal to a1 x cube plus b1 x square plus c1x plus d1. Interval 0 is less than equal to x less than equal to 1. Second interval, that is second polynomial, and that is defined fx, and that is polynomial 2, and defined here a2x cube.
हेलो सर
Hello.
सर वो जो x लिखे हैं 0 to 1 सर ये वो वैल्यू जो गिवन है
Interval
उसी से
wise,
लिखे हैं
actually this is cubic polynomial created from this interval. First interval 0 to 1, second interval 1 to 2, then next 2 to 3.
ओके सर
Okay. So first polynomial we can define in this range, second polynomial define in this range, and third polynomial define in this range. So second polynomial a2x cube plus b2 x square plus c2x plus d2. The interval 1 is less than equal to x is less than equal to 2. Third polynomial next defined here, fx, that is p3x. If px cube plus b3 x square plus c3x plus d3. 1 is less than equal to x is less than equal to, sorry, 2 is less than equal to x and equal to 3. These are the three polynomials we have to define here. And continuity property I have already mentioned now to apply here. Continuity of f of x. Continuity of f of x. First, we have to apply the continuity f of x. The first property, just you see, I have written here continuity property of f of x. This is the first. F1 pi plus 1, pi plus 1. We can define this interval. Any two interval we have to consider for this case. That's just continuity property. P1x1. P1x1, which is equal to F1, which is equal to A1x1 cube plus B1x1 square plus C1x1 plus D1. Whenever you substitute one value in place of x, then this value becomes A1 plus B1 plus C1 plus D1. P2x1. That is just naming as the function of F1. Which is equal to P2x1. Just this value we can represent. A2, B2, C2, D2. When P2 value means this is only for the two value, A2 value I plus B2 plus C2 plus D2. Similarly, P2x2, that is naming as the F2, and that is A2x cube plus B2 x2 square plus C2 x2 plus D2. Whenever you substitute in place of x2 is 2, because it's a second term, 2 we can substitute in this function. Then this value becomes 8a2 plus 4b2 plus 2c2 plus d2. This is one equation. Hello,
सर तो फिर फर्स्ट इक्वेशन में हम 0 पे सब्स्टिट्यूट करेंगे तो फिर हमें d1 मिलेगा ना?
हाँ, यहाँ पे जो 1 है, this is 1 डाल देते हैं यहाँ पे, you can substitute 1 1 1, then you found this value. And P2 same function में
0 भी डाल सकते हैं क्योंकि x का
नहीं, वो लास्ट में कंसीडर करेंगे, फर्स्ट एंड लास्ट फंक्शन है, थर्ड प्रॉपर्टी में यूज करेंगे.
Okay sir. Okay sir.
x0 and xn you have to use the last property. तो अभी P2 जो है यहाँ पे दैट इज ऑल्सो F1, दोनों में F1 लिखेंगे, ये 2 वैल्यू डाल देंगे तो A 2 डाले, इसी फंक्शन में ही 1 रहेगा x की जगह में, वेरिएबल की जगह में 2 रहेगा, तो ये आएगा। एंड P2 x2 अभी डालेंगे तो दिस फंक्शन आएगा। फिर सिमिलर प्रोसेस P2 P3 x2 लिखेंगे, P3 x2 लिखेंगे, दैट इज इक्वल टू ऑल्सो सेम एज द F2 नेमिंग करेंगे, तो क्या हो जाएगा ना, दिस वैल्यू 8A2 8A3 8A3 plus 4B3 plus 2C3 plus D3. The first continuity function on this interval, first we can choose here. This is the continuity on f of x. Again, continuity on f dash x. तो इसके बाद तुम्हारी क्या क्लास है क्या?
यस सर, स्ट्रक्चरल एनालिसिस।
वो कितना बजे हो?
अभी लिंक भी आ गया सर।
लिंक आ गया?
यस सर।
वो तो क्या करेंगे? और 5, हाँ ये 5 मिनट कंप्लीट नहीं होगा एक्चुअली, वी नीड मोर टाइम। तो ऑलरेडी लिंक दे दिए हैं वो लोगों ने।
यस सर।
ओके, तो tomorrow there is no class. I want to one class tomorrow. कर सकेंगे कल ना? कल किसका एंगेज है क्या?
सर
कल तो मैं ले लूंगा 10:30 से 10 साढ़े 10 से, ठीक है?
ओके सर।
कल सर 10 से 10:30 शायद HOD सर लेंगे।
चलिए सर,
सर आपको इन्फॉर्म कर देंगे सर।
ठीक है, मुझे इन्फॉर्म कर देना, नहीं तो सेकंड हाफ में इसी टाइम में लेने से भी चलेगा।
ओके ओके सर।
Okay. Okay, so this example we will do the next class. That is better. If you have no class, then you will continue this one. Okay. और वेट करेंगे 5 मिनट, ये एफ डैश डबल लिख देंगे ना, ये तो कंप्लीट अभी नहीं होगा, बट 20 मिनट में कंप्लीट हो जाएगा ना। और क्लास ले सकते हैं? नहीं, ठीक है, कल ही करेंगे, ठीक है? ओके, so we will discuss the next class. Okay.